Hello everyone. In this video, we are going to look at design for assembly. This is a part of the lecture series of design for manufacture and assembly subject, and the course code of this subject is 16ME315. What is assembly? An assembly is something which is we bring it together, two or more parts, and then there is a relation between the two parts, like a fit or an alignment or a mate, etc., with each other. The relationship is a step towards realizing a larger purpose of making a product so that the end use of the product is ascertained in the fit and form and function. Can you make some of the products without an assembly? Yes. Ideally, it is a product which has an end use, but one that has no assembly of parts. For example, a tablespoon or a teaspoon. So it has a purpose, it has an end use, but there is no assembly here. So do not mistake that all products are made up of multiple parts. There could be a product which has a single part also. So what is that we should understand? The difference between a part and a product is that a part is a standalone one, and it does not have an end use straight away, whereas a product will have an end use. It has a function which it will satisfy. We don't call it as uh, that the product must have uh, multiple components, etc. Multiple component definitely we have sometimes, basically because of various other reasons, which we will come to that later. But products always need not have an assembly. So a group of part put together is not a product, but it is a sub-assembly. Why is assembly required? To achieve the end use of the product so that it will satisfy the design need. Every design comes up because of to satisfy a particular need, and to achieve this need, these products are made. When there is a relative motion between the two parts, we have to have multiple components, and so there must be an assembly there. It is used when one single part is not able to function as a product. Yes, that is why we go for multiple parts. Okay, so we go for an assembly there. It is used when the part has to be broken up into multiple parts to achieve ease of manufacture or ease of transport, etc. etc. What are the conditions to go for an assembly? Now, again, we list the same thing down here. When there is a relative motion required, when there is a requirement for the material to be different because of specific property, like one, there could be an insulation, etc. there, from heat, etc. If it is too bulky or slender and the cost of production can be brought down because of breaking up into multiple parts, then also we can go for an assembly. So to go for an assembly, there are multiple points that we'll have to take care, and these are some of the points there. Now, from now onwards, we are going to look at the various design guidelines for assembly. Okay, it is always we say that this is a guideline and this is not a rule, because guidelines are to be applied so that a designer knows much better what to use, when to use, and how he is supposed to use these guidelines. These are not rules. Simplification of product structure. The first thing in an assembly we always say that is reduce the number of parts to be assembled. Okay, we also saw in the previous videos that if you reduce the part, there are so many other advantages that which goes into that of making of the part, the inventory of the part, etc. So if you can reduce the part, then it is much better. You design the parts to be multifunctional. You also that it should also house something. It should also try and then work as for its own function, etc. there. We will look at this much more in the future slides also. Design of parts for multiple use. Minimize separate fasteners. Okay, fasteners are like your bolt, nut, screws, etc. there. You must not have multiple different sizes of fasteners there, because every time you'll have to use a multiple tool, a different tool to assemble, etc. there. Okay, so try and minimize the separate fasteners. Ensure that the remaining parts are easy to assemble. Design robustness into the products to compensate for uncertainty in the product's manufacture, testing, and use. Okay, even in use, there's a lot of of abuse that happens to a product. For example, a cell phone. A cell phone, when you drop down, it opens out and then falls into three pieces. Okay, all you do is you go pick up all the three pieces, assemble them back together, and then switch it on. It works fine. How does this happen? Suppose I try to fasten the back cover with a screw, etc. there. Okay, because of the mass inside, the battery inside, once it tries to, as it falls, because of the impact, if the mass tries to pushes itself out, the back cover may break. They may break. Okay, so but what happens here is that they have just done a snap fit so that the back cover just opens out beyond a certain force from inside, and then you are able to assemble it back inside properly. So design robustness into the products to compensate for uncertainty in the product's manufacturing, testing, and use. Minimize the cost of assembly with constraints imposed by other design requirements. Try to bring down the cost of assembly. Nobody is going to pay for the assembly. Okay, whether you assembled a part or whether you didn't, you had 10 parts or you have 7 parts, it is irrelevant for the user. The user just understand that whether he can use the product for his particular need. Okay, so nobody pays extra for just because you made multiple parts. Okay, so you try and minimize the cost of the assembly by trying to bring down all the other constraints. Now let us look at this particular example. The overall component of this, the sheet metal one, and then you see that there are these kind of washers, etc. Then there's a requirement that this particular shaft kind of thing must be assembled inside. Now, they had thought of a better design there, and try to do a revision in the design. What they had done is they tried to put a plastic insert here so that the plastic material will try and then hold the component tight, when it goes and sits inside. So they have eliminated all these type of screws, of these screws, etc., or these washers, parts, etc. But the final design was this. Now in this final design, what you see is that there is a sheet metal, and then you see that there is a cut here, now allowing this part, okay, this the protrusion there, okay, to give away slightly away, so that as I push the shaft like component down, it gives away, and then once it gets into the hole, it will spring back. Okay, so the springiness of the material has been encashed here to solve the problem. Okay, now this is the a beautiful example of trying to minimize the parts. So from so many parts, we have come down to just 2 parts now. Okay, look at this, a very simple and a nice example. uh, so the guideline is a part is a good candidate for elimination. Okay, if there's no material different, if there's no need for material to be different or be isolated. For example, whether it should be a thermal insulation or a electrical insulation from other parts, I need not try to make it into two different parts. I can make it into combine into one. So our parts can be combined with other parts when they do not have to be made from different materials. You look at the center one. Okay, there was a lens, and then there was a sheet metal, and then there was a handle, etc. there. Now, how to hold the sheet metal? So there must be also a screw to bring the sheet metal together to hold the lens. But what they have done is they have made the lens as a part of the product itself, so that it is much cheaper. The first one is the most simplest one. The lens, instead of making it of glass, the acrylic itself is transparent, and then it is able to do the same function as that of a lens. Now, this is what is that we had seen. There's a blown up part of this, and next one is the safety hook. Also, you see that it requires 2 parts, and then they have to be assembled together, etc. There. Now, uh, the the DFMA engineers have tried to combine into a single part based on its use. You try to find out really actually what is really is the necessity of that particular part, what is the function that it does, and try to see whether you can put the function onto some other part, or try to answer the same function but without an extra part. Okay, here look at this one. There's no need for service or repairability of this. If there's something wrong with the part, there's an electrical installation, there's a thermal installation that happens. It has been molded into a single part. Okay, and if something goes wrong, there's nothing to be assembled here, etc. Must the part be made into separate from all other parts already assembled, because otherwise necessary assembly or disassembly of the separate parts would be possible. If the answer is no, then the part can be eliminated or combined. Now, the next one we will see is what is designed for no assembly. If we make certain things that there is no assembly required at all, then a designer he strives to achieve that particular situation where there is no you make a design such that there is no assembly at all. Okay, these are these examples. Now what they have done here is between these two parts, okay, you see that the holding etc comes in one direction, so the assembly can happen in another direction. Okay, in the perpendicular way I try to assemble them and then try to do this. More example for the part count reduction, you see that there is a washer and there is a screw here, and for the washer can be part of the you can have the screw, the washer integrated with the screw itself. Okay, here again there is a lever, and how they have achieved the springiness of this lever. They have tried to do it by this part itself being vertical, acting like a cantilever here. Now, for all these kind of things, the material of this part would have been changed. Now, here we have a spring. I have eliminated the spring, so one part has been brought down. The material of the spring may be different, but then I am trying to bring it down by changing the part in a different material, which will help me to achieve the same purpose there. Now, the second guideline is make minimum use of separate fasteners. We have already said there, but one way to reduce the component count is to minimize the use of separate fasteners. It is a very famous saying that the Volkswagen Beetle can be fixed with a set of screwdrivers and a standard 13 wrench. That means all the entire assembly of the Volkswagen Beetle can be done only by these two tools. That means most of the components are of the same size, etc., that you can try and fix it up with the same thing. Okay. Standardize the use of fasteners whenever required. The best way to get rid of fasteners in molded parts is by use of snap fit. We will see what is snap fit. Okay, you have a Pond's talcum powder box. Okay, you open that, and then when you want to close it back, you close it, and then just press, and it gets snapped, and then you get a tuck sound, and then that is a snap fit. Okay, it's very easy that making such kind of the assembly disassembly is very simple. The assembly of the back cover of the previous generation of the cell phones were uh, by the snap fit only. Fastening. What is fastening? Fastening is tying up of two different parts, and then what are the different ways by which to we try and tie up these two parts. Okay, there are permanent fasteners. Okay, permanent fastening we must have studied in our machine drawing. Okay, that permanent fasteners are like riveting, welding, etc. There. Now we can also use adhesives. There are some adhesives which are permanently bonded together. Okay, but there are temporary fasteners also. Where do we go for permanent fastener, and for uh, temporary fastener? Temporary fasteners are used where like in screws, etc., where I want to disassemble a part. I use split pins, screws, or circlips, etc., where I can disassemble the part. Whereas in permanent fasteners, I understand that it is joined for a lifetime, and there is no requirement of the parts to be separated again. For example, welding between of a table, etc., like that. Snap-in devices, permanent or temporary fastening. Okay. Uh, Achieve assembly and retain attachments by utilizing the elastic properties of components or device. You can achieve the assembly and retain the attachment by utilizing the elastic property of the component or device, and then try and use the snap-in. Okay, that is what I told you about the cell phone back cover getting snap fit, etc. There again, you see that the snapping part is slightly gives away and then again snaps back into the original position. You can also use adhesives. Adhesives, what are the adhesive? They are something like a gum where we try to use a or a bond between two materials. Okay, what are the advantages? Generally, they are less costly. Okay, minimum of component distortion. The appearance are not affected because there's nothing to be machined or anything like that. It's a very reduced weight is there. Great damping of mechanical vibration because of the adhesion. The vibrations may also be come down. Okay, wide area of stress distribution. Galvanic corrosion is also minimized because of this, because otherwise when I use uh, these fasteners, etc., okay, there are it is bound to get corroded. Now, mechanical fastening vis-a-vis with that, between the adhesive fastening and the mechanical fastening, they have their own advantages. They are generally very stronger, and some can be reused. Okay, and they all most of the time they can be reused. Well, they are useful over a wide range of temperatures. So, whereas in adhesive, you cannot use at a very low temperature or very high temperature. Okay, but whereas in mechanical fastening, you can try and do. What I mean by mechanical fastening is that by putting a bolt and a nut and then trying to tighten certain things. Okay. Well, the dual function, for instance, component mounting also could be done, and then the tightening also could be done. Okay, so it can act as a dual operation. It is a well established technology with no special training requirement being done. Okay, the hierarchy of fasting goes like this. If I have to arrange the whole thing, all the four different types, by way of which is very costly. Now, the snap fit is the most cheapest one. And then you have the sheet metal crimping. You have a sheet metal, and then olden days, if you see in houses for routing a wire on the wall, they will be using a wooden strip. On that, these kind of metallic strips will be there, and they will be crimped together. Now, rivets are the next level. Rivets, where do you see in most of the sheet metal usage of body, etc., like trains or the ship, etc., the hull of the ship, when they make all these things, there is a overlapping of the two rivets. In olden days, they never used to have the welding. Welding was not that much of advance at that time. But now welding has replaced most of the places, but by most of the times where you have to use the rivets. And then the costliest one is the screws. In design for mechanical, design for manufacture and assembly, we advise you that as a designer, try and use the screw only when it is required. And whenever you use a screw, it makes the part costlier. Try to always strive for snap fit. Okay, but if you have to go for a screw where you have to do the threading operation on both the parts, okay, then you may have to go for it. So it is up to you to decide which you want to use it. Product with base components for locating other components is a third guideline. This guideline encourages the use of a single base on which all other components are assembled. Okay, I'll show you the drawing. It will be easy for you to understand. The base provides a foundation for the consistent component. It locates fixtures, transporting, or orientation, rotation, etc., and the strength. For example, look at this part. Okay, I see this the base part, and on all these things get assembled onto this. So when I want to carry these kind of things, the whole thing, this looks like acts as a tray also, and it also uses as a locating of the part, and the whole thing itself is a part. Okay, this guideline encourages the use of a single base on which all the other components are assembled. The base provides a foundation for consistent component location, fixturing, transport, orientation, and strength. Okay, the next one is, do not require the base to be repositioned during an assembly. If automatic assembly equipment such as robo or special designed component placing machines, you'll have to take it and put it there or turn it and keep it, etc. there. Okay, then you should understand that you don't have to reposition the component. If you reposition, then the orientation, everything gets changed. Hence, it is advisable that the product does not require repositioning of the base during the assembly. So during assembly, try to have the part in the same orientation. Okay, that is how you will have to try and decide your design. Okay, we have come to the end of this particular video, and then let us try and do the an evaluation of or the summary on what we have studied now. What is the difference between a part and a product? Okay, a part is a single component; it does not have an end use. A product could be a single component or multiple component, but it has an end use. It has a function for which it is designed for, and then it satisfies the function. When do you combine two parts together into one part? When there's no relative moment, when there's no electrical or insulation or thermal insulation required, then I try and combine them into a single part. When I don't have to, it is very too long or bulky to be transported, etc. I try and combine into a single part. Why should why should uh, uh, why should you identify one part as a base part during the assembly? The last one that we have said, it will be easy for locating, and then it will bring down the component number also, and then locating, transporting, etc. I try to have a base part on which all the other components get assembled. It's much easy for assembly. What is the hierarchy in the fasting based on the cost? Based on the cost, if I say the cheapest one is a snap fit, and then you have the sheet metal or the crimping, etc. there. Then the third one is the riveting, is much costlier to that, and the most costliest one is the mechanical fastening, where you have a tapping or a threading operation, and then you use a bolt and nut and then try to do it. Okay, so we have looked at the four guidelines of design for manufacture or in assembly. Okay, for design for assembly, we have looked at four guidelines. More guidelines are in store. We will meet in the next video. Thank you very much.